All right, and welcome to what should be the final piece of our Research Methods and Basics module, or Module 1, uh, where we're going to be talking a little bit about the concept of reliability. And after this, again, we have practice problems to complete, and there are homework assignments that are due as well. So, again, we talked about validity already, which refers to the accuracy of our measurements, including making sure that we're exclusively measuring what we want. Reliability, the other dimension that we want our operational definitions to be high on, is the extent to which we have consistent measurement. So reliability is all about consistency. Validity is accuracy, reliability is consistency. That ties into the notion of error. So error is a term that has to do with anything that creates an inconsistent measurement. We want to make sure if we're measuring a variable that doesn't change, that the measurement also does not change. If a measurement's real erratic and the variable itself isn't changing, that's a very unreliable measurement. We can't put much stock in any of those measurements. This ties into the broader idea in research design of control. We want everything as consistent as possible, and we certainly include our measurements in that. We want to make sure that we can rely on those measurements, that we know that individual measurements aren't going to fluctuate a lot when the variable itself isn't moving, that there isn't a lot of noise or a lot of error in those measurements. Again, reliability is all about consistency. You can have reliability without actually having accuracy. Obviously, we want both, but if we're just talking about reliability, all we mean is consistency. You can have a measure that is totally inaccurate, but is extremely consistent. It would still be reliable. Wouldn't be a great measure, still reliable. We'll talk a bit more about that in a moment. But here are some common subcategories of reliability. Oftentimes in research that involves having raters or judges view, say, social behavior. So in those studies, say we have like a couple in a romantic relationship. They sit in a room and they talk about something that causes conflict, and we want to code it for different types of interactions. Tone of voice, who's talking over who's more dominant, etc. We're going to use raters for that. Here's the problem. Different raters may interpret the exact same interaction very differently. That would be an unreliable measurement. How the variable is measured depends a lot on which rater is sitting in front of it. So we want high inter-rater reliability. We want to make sure that our different raters are consistent in how they assess the same social behavior, the same information. So again, we want to make sure that there is a consistent evaluation there. The way that we do that is by stamping out that subjectivity, usually by coming up with really consistent criteria that we use for coding. A bit more of a common approach, sometimes with, say, tests of personality traits, IQ, self-esteem, that sort of thing, we want to make sure that if the underlying variable isn't changing much, that the measure shouldn't change much as well. We don't want it to be affected by temporary things like mood or time of day or any of that sort of thing. So we might measure test-retest reliability. The way that you do that, you give people the same test multiple times and you correlate them. You make sure that they're very consistent. So if I give you an IQ test today and you score 105 on it, and I give you an IQ test in a month and you score 105 on it, that's a very reliable, consistent measure. If you score 105 today and 125 next month, that's an inconsistent measure. The variable, your intelligence, did not change by that much in a month, almost certainly. So we probably have an inconsistent measurement. Now I don't know which one of those is a better reflection of your actual intelligence. Again, both of those are measured with correlations. We'll talk more about both of those way in the future when we discuss correlational analysis. So let's talk about reliability and validity at the same time now. And I always find the best way of doing that is by putting a little bullseye together here. So let's say that this bullseye reflects the construct that we're interested in. And the closer to the center of the bullseye you are, the more accurate your measurements become. Let's say these blue dots all represent individual measurements on that variable. We measure it, we'll say 20 times, and that's where they fall. So a measure that has reliability but not validity is going to have a lot of consistency of measurement. Your scores are going to be grouped together very closely, but they're not accurate. They're consistently inaccurate, in fact. An easy example to think of, imagine a bathroom scale. You step on it, it tells you your weight. Your real weight, the actual value on that variable, is 150 pounds, we'll say. A scale that was reliable but not valid might constantly tell you your weight around 180 pounds. That's consistency, and it's not validity. You are reliable, but you're not valid. You're consistent, but you're not accurate. So the measurements we know are going to be tightly grouped together, but they're not giving us the right information. Here's the opposite problem. Let's say again that your true weight is 150 and you step on that scale a bunch of times and the scores are just all over the place. Sometimes it tells you you weigh 135, sometimes 162, sometimes 189, sometimes 114. Just tremendous inconsistency there, but on average, if you average them all together, it would give you something very close to your real score. That is a measure that is valid, it's accurate overall, but the measurements are so inconsistent that you can't put much stock in any single measurement. You need to get a bunch of measurements and average them to, again, get something close to the right answer. That's a different set of problems. The worst case scenario is a measure that is neither reliable nor valid. Scores are both inconsistent and inaccurate. A scale that, again, gave you a really erratic set of weights, but they all were higher than your true weight, that would be a measure that is not consistent, it's not reliable, and it's not accurate or valid, even on average. Of course, what we really want is a case where our scores are very consistently grouped together and very accurate overall. It's easier said than done, but that's the ideal. So that's how reliability and validity kind of group together. Notice that reliability affects how closely grouped those scores are to each other. Validity affects how close those scores are to the center of that bullseye, to an accurate measurement. So this is our second point of emphasis for Module 1, and again, that's something that's really important. Reliability and validity are crucial to good research design. We put tons of work into making sure our designs are as reliable and as valid as they possibly can be. But a lot of times there's trade-offs. My old stats instructor used to call it stats or methodological whack-a-mole, that you push down one problem and another problem pops up in a different place. So if you've ever played that whack-a-mole game, if not, I don't know, look on YouTube. But generally the idea is a lot of times smacking one problem down increases the likelihood of another. So we have a lot of trade-offs happening. So for example, studies that are more internally valid, where we're more certain that we're assessing what we're trying to assess, usually you have to exert a lot of control over those studies to be sure that's the case. That usually results in lower external validity. The environments get more artificial and sort of more different than real-world environments, and so it's harder to generalize. It's harder to be sure the way people acted in that study reflects real-world behavior. If you take a research methods class down the line, you're going to hear all about reliability and validity and how they tie into different approaches to research. For now, just know we want both to be as high as possible. Each form of design has its own pros and cons. For example, research conducted in a lab, like inside of a psychology building, usually you can have a lot of control over that environment. So you can have strong internal validity, but people's behavior might be more artificial. When you do what are called field studies, you go out into the real world and you observe people as they naturally are acting. That's great external validity. People's behavior is natural because they don't even know they're in a study. However, you have a lot less control over the environment, so your internal validity is now very poor. It's very hard to guarantee you're assessing what you're trying to assess. Some consistent factors: get a sample that's as representative as possible. As we've already talked about, that's almost impossible to fully do, but make it as representative as you can. Make your operational definitions closely related to the construct as much as possible, and equalize everything that you possibly can. Everything should be equal across participants and conditions as much as possible, except for whatever independent variable you're manipulating. So to summarize, be familiar with these four big subcategories of reliability and validity. Know that different designs each have their own issues. They also have logistical issues, just practicalities of running them, and that generally we pick the design that is the best fit for our question, but also fits our logistics, fits the resources that we have access to. So that is the end of Module 1, if you've gone through them in the right order at least. Next up, again, work on your practice problems, work on your homework, and again, try to get as familiar with how to approach problems in these areas as you can. I'm also, of course, available via Skype or via our class's discussion board, so feel free to contact me there or via email. All right. Again, complete those practice problems in the homework assignment and then move on to Module 2 when you're ready.